Good afternoon, this is Schweitzer, and I'm looking to give you the answers for the preliminary quiz 7. A couple things I'm going to note here about this particular first question is energy is on the left side, so I'm endothermic. I have a solid X, 2 Y's, okay, 3 Z's, gas, and then a liquid W here. So keep in mind the liquid and the solid are not going to have any effect on equilibrium. Endothermic and slightly larger K values, a little bit bigger than 1. Either way, it's very ever so slightly product favored. Okay, so all right, so we're producing Z, and I want to know what changes could I do here that might increase the amount of Z that I'm getting. All right, so we're looking for a shift to the right in this situation. So increasing temperature, all right, and the energy is here to the left side, so correct, I'll shift to the right. That is correct. Adding more X. X is solid, so no effect. Increasing the size of the rigid vessel. Alright, so again, changing the size will change pressures. Changing pressure will increase the size, lowers the pressure, and then we need to make an assessment about gases. I want to cause higher pressure because that will counteract my stress. Okay, so I have only one gas here. So a shift to the right increases pressure, and therefore increase the number of particles hitting off the inside container of the wall, and therefore yes, shift to the right as pressure increases. So this is going to be 1 and 3 only. Number 2, the chemical company is in business of selling Z. Okay, so which of the following statements is false relative to the reaction under various conditions? If the quantity of W increases, the concentration of Z will also increase. W is a liquid, so it's not going to change concentration. When the concentration of X remains constant, the reaction has reached equilibrium. The answer is no, and that's because the concentration of X really is never going to change. But if concentration of Y were to hold constant, well then yes, we would be at a system where all the stuff is holding steady and we would be at equilibrium. C, reducing X will have no effect on Y. Yes, solids have no effect. Okay. Increasing the pressure of Z at equilibrium will reduce the quantity of W produced. Okay, so it says here, increasing the pressure of Z, all right, we'll shift to the left, and we'll reduce the quantity of W produced. Yes, this is true, and I have quantity here because W will reduce quantity. So I actually have 2 yeses and 2 nos in this problem, so there's a little bit of a glitch in this problem. I could change this, we'll reduce the concentration of W. This would then be no, and all 3 of them would be no. Either way, just be aware of that situation with that problem. Okay, number 3. A 1 liter reaction vessel contains 2 moles of each reactant, 1 mole of each product. Okay, which the following is true. So they want you to make a quick little assessment of Q and then answer the question. So in this case, my Q, it's in a 2 moles in a 1 liter vessel. So 2 divided by 1 should be 2. Change that. All right, 2, and then. Right, and then of course 1 mole of each product. Okay, that is only going to be one that's going to matter is B. It'll be 1 mole divided by 1 liter, and this is going to be 1 divided by 1, and then 2 divided by 1 is going to be 2. Okay, all right, should be right. 2 moles of each reactant, 1 mole of each product. Okay, again, let's redo that. Did it backwards here. 1 mole of each product is going to be 1 divided by 1 is 1, divided by, and then the reactant is 2. 2 divided by 1 is 2. So once again, I had it originally here as well. 0.5 is my K. Flipped it, it's fine. Okay. All right. So which of the following is true? Okay. Number 1, the reactant is at equilibrium. Now, this is a problem which has a little bit of missing information, okay? And I could put K equals question mark up here, and that might be more helpful. But in some sense, we don't know where our K is. We don't know if we're going to shift to the right or shift to the left because we don't know an endpoint. So the answer is no. We don't know K, so we don't know which way we're going to go. We don't know if this 0.5 is going to get larger or if it's going to get smaller. The reaction is proceeding towards reactants to attain equilibrium. Again, we don't know K and we don't know what's going on. So we cannot answer that question for certain. The reaction quotient is 0.5. That's a yes, therefore C is my answer. All right, going below here. Short answer. Sodium hydroxide is mixed with iron 3 nitrate forming iron 3 hydroxide. That would be a solid. 1. For the reaction, for the solid reaction, indicate the following, the net ionic equation. Now I have it written this way. You could turn it around and put the solid on the left side, which would correlate to KSP. So, which is fine. Either way, they're both correct. I also balanced it easily as well. They're almost always going to say the balanced net ionic equation, so make sure you balance these things. If the previous reaction mixture was 100 milliliters of 0.1 and 100 milliliters of 0.05, iron 3 nitrate, answer the following questions. Write the KSP expression. That's located right here. All right. It's a little bit bigger, maybe. There we go. Okay. There we go. All right. So I did that right here. Cubed here. Concentrations of each. All right. Determine the concentration of each ion. Okay, this typically goes with a point. Now again, I'm going to use the dilution formula or the volume doubles, so the concentration is cut in half. So you can use either one you want. I'm not going to show all the details here, but here it is, I guess, one part of it. Actually, right here. So this is 0.005 and 0.025. That's just the concentrations cut in half. But you need to make some clarifying statement, or just show what you did. Just divide it by 2. All right. Then determine Q. Okay, we're going to plug in our concentrations here, 0.025, 0.005, don't forget to cube it. There you go. And then finally, I'm going to sort of make an analysis of my Q. Q is greater than K, so Q will be getting smaller, and that means I'm shifting, reactions will be shifting to products, causing reactants will be shifting to products, causing precipitation. Okay, so let's hold on a second. So Q is bigger than K. So in this case, we're holding too much. Our stuff is too big. So products will shift to reactants. Now again, in this thing, I'm comparing this value right here. All right. This value right here, make sure I got it right, to this value right here. All right, so in this case, Q, negative 12 is bigger than negative 16. So Q is bigger than K. All right, so Q is going to be getting smaller. These numbers are too big. So those represent solubilities. They're too much. So products will shift to reactants, causing precipitation. Remember, K is proportional solubility. Concentrations are too high. All right. Next problem. Given the following reaction at equilibrium in a closed container at 500 degrees Celsius, predict the effect of each of the following changes to the concentration of C. So really you have to say what happens to C. You can't just say shift left or shift right. So I make a clarifying statement and then answer the question. Reducing the volume. Okay. Reducing the volume will increase pressure. So I got to make an analysis of my gas pressures here. I have A and B. There's 2 gas particles on the left and 1 on the right. So shifting to the right would cause pressure to go down. Shifting to the left would cause pressure to go up. So my stress is that I'm reducing volume, I'm increasing pressure. So I'm increasing pressure. Therefore, I want to reduce pressure. So I'm going to shift to the right to reduce pressure. And C will increase. Addition of D. There's no D here. D is right here, but it's a solid, so no effect. Indicate one way in which the value of K will increase. Change. To increase the value of K. All right, so just one little clarifying piece here. So that I don't know if I mentioned this in class or not. At least yesterday I did not, but either way. In this case, remember that K is a ratio of products over reactants. All right, products over reactants. All right, so in this case, I know I'm going to shift to the right. Okay, so I'm going to take reactants and produce products. All right, and good enough. So as I do that, I'll have more numerator, right, and less denominator. So K goes up. That's important. Didn't really, I meant to mention that yesterday, but I did not. Either way, most years I do. So either way, that should be the end of our quiz, and that is it. Thank you very much, and have a nice day.